Yes, now I am able to share. All right, all right. So the screen is also recording right now. Yes. Now I can continue.
Now participants
Just let me. What? What happened?
Your screen is visible to me, sir, now.
Yeah, I am sharing. Okay. So now let us see the scope chain today, and then followed by this callbacks and event loop everything. Okay, it will take 2 to 3 hours of time. So let it be, because these are the most important topics. I would like to club them together today itself, and then tomorrow we'll be directly jumping into DOM. Okay. And DOM will not take more than 2 sessions. It will take only 2 sessions. And only thing is you need to practice a lot. Okay. So this is the JS file, and let me load this Arvind.html file here. All right. So this is my console. Yeah. So now let us discuss the scope chain. Okay. Scope chain. And before coming to scope chain, I wanted to show you something let me make a function. Okay. Function test. Let a is equal to 10. Okay. And I'll call this test and I'll log this a. And could you expect what will be the output? I want you guys to expect something. 1 second. Yeah, come on. So just try to expect what will be the output.
Variable A is not defined. Initialized. Initialization error.
Okay. So initialization error means, so there are 2 kinds of error.
You are accessing the variable A before initializing it. It
so
shows
before
like
initializing, that's one error, right? So
yes.
Cannot access A.
The variable A initialization.
Yes. So this is the first option, and the second option is I'm giving you 2 options, and the second option is A is not defined. Yeah. Now you tell me, will we get the error or A will be printed? So 3 options I am giving to you, and A will be printed. Either it can be a value of 10 or undefined, or that is one option. And the second option is cannot access A before its initialization. Okay, A is a variable, and A is not defined is the third option. And out of these 3 options, you pick one option. Everyone, I'm asking everyone to pick one option, and you have to tell me which will be the answer. So if possible, can you give an overview of previous 2 classes?
Actually, A is not defined, sir.
Yeah, Kiran, I'll do that. Okay. See, let me tell you first. The only thing is call stack you need to understand. So I would like to make a recap of call stack. So I'll create a variable called let A is equal to something like 20. Okay. And let B is equal to something like 40. Okay. And then I'll create a function like this, function test. And in that test, I'm going to make a console log of hello, something like this, some message, and then let some C is equal to 20, 22, something like this. And I would like to write some code. So C is equal to C or 2, and C is equal to C ampersand 2, something like this. Okay. And return C. I wanted to return C. Actually, Kiran was not there, so I just would like to even recap that callback call stack also. Okay. Now I'll be calling this test function. And I told you there are how many parts of memory are there. So in the random access memory, there are how many kinds of memory are there?
3 types of memory.
3 types of memory are there. Yeah.
Stack.
One is code memory. First one is, so let me write here, code memory. And what is the second one?
Memory.
Stack memory. And what
heap
is the
memory.
one? Heap memory. So heap will have huge size compared with remaining other two. Okay. Code memory is the one. Code memory is the one which will store whenever this code gets compiled. What will happen? This will be converted into machine code, right? mission code. So that mission code means all the instructions will be converted into some binary format like this. Okay. Something like this. Even I don't know in which format they will be converted. Okay. Something like this. So this kind of mission code will be generated whenever we compile this particular JavaScript code. And this mission code will be fetched into what? It will be fetched into RAM, right? So in this RAM, this mission code will be fetched into the first memory, which is code memory. Okay, I'm making it as one. That means it is the code memory. So all this binary mission code can be stored in the random access memory. In which part of the random access memory? In the code part of the random access memory. And here is our CPU, and the CPU will keep a counter, program counter, we say that, and it will start at the first instruction, and it will continuously serially executes each and every instruction, right? And there is one more part of the memory which is called stack memory. Okay, I'm making it as 2 in circle, so that means it is stack memory. And there is another part of memory which is heap memory, and we are not going to discuss about heap memory as of now. And we will discuss what is the stack memory and what is this is actually called as call stack. Okay, so stack memory is actually called as call stack. Okay, now what will happen is that whenever the CPU executes the first instruction, so there will be something created here. So this is what? This is stack memory. Okay, now I zoomed this particular stack memory here. Okay, because I wanted to write a lot of things inside. So firstly, there will be some amount of memory created to store the variables which are in the global context. I will tell you what are global context. Global context is the one where the variables are declared in the global space. What is meant by global space and functional space? Whatever the variables that are declared inside of a function are called as local variables, or the function variables. Okay, so now inside this test function, how many variables are there? Only a single variable, which is C, is there, and it is called as local variable since it is present inside a function which is test. Okay, now coming to this A, B are 2 other variables, and even this test itself is also a variable which is a function variable. Okay, these 3 variables which are A, B and test. So these 3 are the variables which are directly present inside of the global space. I mean, they are not present inside of any other functions. So this kind of variables are called as global variables. Did you understand this? Global variables.
Yes.
So firstly, there will be some part of the memory will be created on the bottommost of the stack memory. On the bottommost of the stack memory, some part of the memory will be created, and that will be for global execution context. So what do I mean by global execution context? Where all the variables which are in the global scope will be stored. So how many variables are there in this particular code in the global scope? 3 variables are there, right? And what are those 3?
A, B and test.
Yeah, A, B and test. So A is been assigned with what? Nothing. So whenever the first instruction gets executed, what will happen? 20 will be assigned to it. And whenever the second instruction gets assigned to it, 40 will be assigned to it. And whenever the CPU reads from line number 3 to line number 8, what will it understand? There is a value which is a function value is assigned to the test variable. So this is going to be a function like this. Okay, you got this or not? So let me make it a little bigger. I'm making it here. Okay, now what is the first one? This is the global execution context, and in that how many variables are there? A, after executing first instruction it will be assigned to 20, and B, after execution it will be assigned to 40, and test is the variable which is assigned to a function. So I'm putting this kind of curly round braces which indicates that it is a function. A function value is been assigned to it. Now after executing 8th line, it comes to 9th line. Okay, so when it reads for 9th line, what is this 9th line?
Calling the function.
Yes, calling a function. So I am making a call to the function test. Okay, that means whenever you make a call to any function in JavaScript, what will happen is that some part of the memory will be created on the top of the stack to execute that function. Okay, on the top of the stack means what? That means just just about the global execution context. Okay. Now this red color one is the functional execution context we call, and this is for test. Okay. So test execution context, EC. EC stands for execution context. So test execution context is the one which is created for this test function because we made a call at line number 9. Now after making a call to this test, what will happen? There is a text execution context got created on the top of the global execution context. So now this is much like the global execution context again. And how many variables are there within this test execution context? Only a single variable, which is C. Okay. And what is the first line in this test execution context? Console.log some message, right? And that message will be printed on the console, which is hello. Okay. And this one will be printed. And after that, there is another variable, which is C. So for C also, there will be a memory space created within this context only. Okay. And C will be assigned to 22. Okay. And C, we made some processing. I don't know what will be the answer. So C or T, C or 2 is how much? Let me convert it into binary. So 2 11s are 0, and 2 5s are 1, and 2 2s are 1 remainder, and 2 1s are 0. So 1 0 1 1 0. So this is the binary conversion of number 22, and 2 means what? 2 means 0 0 0 1 0. So this is 2. So when we make a OR operation of these two, so we will get 1 1 0 1 0. That means the same number we are getting, which is 22. Okay, so after executing this line, what will be the value inside C? It will be 22, and C is equal to C ampersand 2. That means 1 0 1 1 0, which is for standing for 22, and 2 for 2. What is the number? 0 0 0 1 0, and ampersand of both of these will be 0 0 0, and 1 will be 1, and remaining all are zeros. Now if we convert back it into decimal, what will happen? 1 into 2 power 1, so it will be 2. Okay, so at the end, the C will be assigned back to 2. Okay, after executing this line in C, what will be there? 22 will be there. After executing this line in 7th line, what will be there? C will be assigned back to number 2. Okay, now when the CPU reads the line number 8, what will happen? When CPU reads this line number 8, this that means it is the end of the function, right? So the functional execution context got done. It got done executing it. Okay. So what will happen is it will get erased. Okay. So it will be getting erased like this. Okay. It will be getting erased from the RAM. And then that's it. Now, from where we actually got all this, after executing this line number 9, that means we are done with the execution of line number 9 also. So then the compiler, the controller moves to line number 10, as there is nothing after line number 10. So the entire program need to be erased. So the global execution context will also get erased, and the RAM will get free up. Okay. Now there is nothing inside it. So the program execution got completed. Did you understand, Kiran, till now? Hello?
Yes, sir.
Did you understand this till now?
Yes, sir.
So conversion of these numbers, you were there, right? For this bitwise operators.
Yes, sir.
So you understand, right? Everything, no issue, no doubt, right?
Yes, sir.
Yeah. So then let us move on to hoisting. Very briefly about what is hoisting. So I'll again make a stack memory. So now I am going to deal with the stack memory only all the time, because we don't need what is there in the code memory, of course, and we don't need what is there in the heap memory as well. Okay. So now what will happen when we make there is another way to declare variables. There is another way to declare variables is by using the keyword called where. So this is where keyword, and this is let keyword, and here I'm going to create a variable with where keyword. So we can create variables by using either let keyword or by using the where keyword also. So I'll create another one, which is name, and Arvind is going to be assigned for it. And I'm just going to log both of these two, just C and name, something like this. And I don't want this hello message to be there. Okay. So now you see it got printed something over here. Now let us analyze again how the things are going to happen with this. Okay, firstly, what will happen? How many variables are there in the global execution context?
2.
Three, sir. Three.
Functions are also
Three.
variables, right? I told you.
Yes, sir.
I told you functions are
Yes,
also
sir.
variables. So 3 variables are there in the global execution context. Now, can you tell me how many? Let me write it here: global execution context. And in test execution context, how many variables are there in test execution context?
Two.
What are they?
C and name.
Yes. So 2 variables are there which are in the test execution context. Now A is the one which is declared with a keyword called where, and B is the one which is declared with a keyword called let, and test is the variable which is declared with a keyword called function. Okay. Now within this test execution context, C is being declared with a keyword called where, and name is declared with a keyword called let. Actually, even declaring a function by using function keyword is another way of creating function variables. Actually, we can also use where let also for creating function variables, but here we are making by using function keyword. Okay, so we are going to cover all the topics related to hoisting now. In hoisting, what will happen is that in hoisting it is, my handwriting is really bad. Okay, so in hoisting, what will happen is that before execution, execute means execution. Before execution, all the variables. Come on, tell me someone. All the variables
With where keyword are
which are
assigned
declared,
with
which are declared with where
where
keyword.
keyword are assigned with not undefined.
Yes, assigned with undefined. So firstly, what will happen? Will the test function execution context will be created initially before execution? What will be created first?
Global execution.
Yeah, function execution context will be only created when the function gets called. So till now, before executing this first line, we did not call this function, right? We are actually calling this function at line number 8. So initially what will happen? Global execution context gets created, and then how many variables are there which are declared with where keyword?
1.
In the global execution context, how many variables are there which are declared with where keyword? 1.
1.
So that will be assigned with a one undefined value. Okay, so this is what hoisting is. Actually, this way of
Why it is
before
happening?
see, this is what hoisting is, and it is what done in the JavaScript.
Okay.
Okay, so we are here to learn why, not why, but what happens. Okay, of course they made it like that, and it happens. Okay, so that's what the advantage of using where keyword. Okay, and now this way of assigning undefined value to the variables before their execution is called as partial hoisting. Right? So that means variables which are declared with where keyword will be assigned to undefined before its execution. Okay, that's called partial hoisting. And coming to complete hoisting, variables which are declared with function keyword, like the functions which are declared with function keyword, they will be fully hoisted. That means the value will also be assigned. Okay, now there is a variable which is declared with function, right? So the value will not be undefined for it, but the value will be going to be the function whatever the developer writes here. Okay, so this is what fully hoisting. Okay, now variables which are declared with let keyword will not be hoisted. Okay, did you understand? 3 points: variable which are declared with where keyword will be hoisted partially. That means undefined value is going to be applied further. And variables which are declared with function keyword. Actually, functions, whenever we are assigning some function only, then only we can use this function keyword. So variables which are, the functions which are declared with function keyword will be hoisted fully. And variables which are declared with let or const. Const is another type of declaration of variables. So variables which are declared with let or const will not be hoisted. Okay. Now what will happen is that this got hoisted. Now the execution starts. So this all things happens before the execution context gets created. Okay. I mean, before executing the first instruction only, all these things happens. Now what will happen? The first instruction will be executed where we are assigning the variable a to 20. So now undefined will be erased. Okay, let me erase that. Undefined will be erased, and what will be assigned to it? Value 20 after executing first line. Now after executing second line, there will be another variable created which is b, and that b will be assigned with a value of 40. Okay. Now after this is completely the function definition, so nothing will happen. And at line number 8, we are making a call to the function test. So what will happen? What will happen? Since we are making a call to this function, yeah, functional execution context will be created on the top of the global execution context. Now this is what? Test execution context. Okay. Now what will happen inside this? Same movie, same cinema that has happened till now. So again, in this particular function execution context, how many variables are there? 2 are there. And out of these 2, how many are created with where keyword? So before executing this 4th line only, all these things happens, the hoisting. So the C variable, which is declared with where keyword, will be assigned to a value of undefined. Okay. And
Sir,
then
can I ask one thing?
Yeah.
Like we are using where, then this undefined is occurring. Okay, but what if we use let, then hosting will not occur, means that in global execution phase we will get the exact values right there.
No. Whenever that line gets executed, then only the variable gets created. Until then, the variable will not be created. But what I'm telling is that in the hoisting, variables which are declared with where keyword, even before executing that instruction only, this thing happens. Like the values gets undefined. Okay.
Okay.
Yeah, just hold on. I'll be showing a lot of examples for this. And then after executing this line number 4, what will happen? This undefined will be removed, and what will be assigned to it? After executing line number 4, what will happen?
22.
22 will be assigned to it. And after executing line number 5, what will happen? Name will be assigned with Arvind. Okay. And then after this, we are making a console log. So what will happen? These 2 things got logged out at line number 6, you see. And then when it reads this line number 7, that means the function execution context got completed. So what will happen? This entire memory will get erased on the top of the stack like this. So now the functional context got erased, and after that means we are done with the 8th line execution also. The control moves to 9th line, and from 9th line there is nothing. So what will happen? The program will get terminated. I mean, the entire program got completed its execution. So the stack will become empty now. Okay. So now to show you a lot of examples on this, wait some time, I'll tell you. Okay.
Okay, sir.
So just I'll make a log of a variable called a, and I'm making a declaration of a with 20. And what could you expect? What will be the answer? How many variables are there in the global scope?
1.
Only single variable, which is a. And whenever the global execution context gets created, before execution of the first line only, what will happen? Since a is a variable which is declared with where keyword, that will be assigned with undefined value, right? So whenever the first line gets executed in the RAM, in the global execution context, there is a variable a which is assigned to undefined, right? So that undefined will be printed on the first line. And you see undefined printed on the first line, and on the third line it is printing 20. Let me show you how this thing happening in the memory level. So this is what is this?
Call stack.
Yeah, it is
Stack memory.
Stack memory. So in this call stack, firstly what will happen? There will be a global execution context gets created. This is what the global execution context. And how many variables are there in the global execution context, which are declared with a keyword called var? One variable. So a will be assigned to undefined. When? Before executing the first line only. Undefined before executing the first line only. And now after hoisting, this process of assigning undefined values to var declared variables is called hoisting. And after hoisting only, this code will start getting executed. Okay. Now the first line we are trying to print the value in A. So what will be printed? What is there in the value of A?
Undefined.
So undefined will be printed. And you see in the first line we are printing, we are getting undefined here. Okay, since we declared a variable by using var keyword, that got hoisted partially. Okay, now what will happen in the second line? I am making an assignment of 20 to the value a, to the variable a. So what will happen? Undefined will be removed and 20 will be assigned for this variable a. Okay, now after executing second line, we'll come back to this, come to this third line, and in the third line we are trying to print the value of a. Now what will be printed? 20, right? So 20 got printed. Clear? Saigiri Vardhan, front-end developer. What happened to you, Saigiri? Hello? So this is what hoisting is. And let me show you some more examples also. What if I declare it with let keyword? Since when we are declaring with let keyword, what will happen? It will not be hoisted.
It's
Right?
error.
Yeah, this is our call stack and global execution context got created here. Okay, and within this what happens? Since let a variable a is the only variable in the global execution context, it will not be hoisted because we declared it with let keyword. So in the when we are reading this first line, what will happen? There is nothing like a in the RAM, right? There is nothing like a in the global execution context or in the RAM. So what we need to print? We will get an error that a is being used before its what? Initialization. That means we are initializing a in line number 2 and that is not yet created in the memory. So how can we log that? We cannot log that, right? So that's why we get error. Let me save and you say uncaught differentiator cannot access a before its initialization. You got it?
Sir, not defined and enduku ravatledu sir akkada.
See, when we don't define the a, you see, when we don't define a, in that case, you will get the error called a is not defined because there is nothing like a in the entire global execution context, right? So how can we get the value a? Okay, know the difference between two things. Actually, JavaScript knows who are the variables and before its execution only. Even let declared variables also known by the JavaScript, but still the variables, that's why it knows priorly how many variables are there and out of them how many are declared with var keyword and how many are declared with const and how many are declared with let keyword before its execution only. So that's why since JavaScript knows that there is a variable which is a, but that is been initialized in line number 2, but we are trying to access that in line number 1 only. So it is throwing an error called we cannot access the variable a before its initialization. But when the variable a is not at all present in the document, the file, then what will it show? It will show that there is nothing like a variable a. That means a is not defined. So let me save that and you see a is not defined. Did you understand?
Yes.
Is this
Sir.
clear? Yeah.
Yes, sir.
Now I'll take up some more things. Like I'll log the func over here. Okay, func variable, and I'm going to declare this func with func keyword or function keyword, and I'm going to make some. Let me create some variables inside this. Let a is equal to 20. Let b is equal to 30. And console.log a plus b.
Hello.
Okay, so hello, Navin. Navin.
Yes, sir.
Navin, you stop the record. You stop the meeting because it is going to be ended up within 1 minute. So we have to exit out of this. Okay.
Okay, sir.